okay, if I were looking at this, I would, again, look at the 5 questions and try to determine which looks the easiest to me. That's a tough call sometimes. I mean, you're looking at things and you're wondering what's easy, what's difficult. I'm going to say 4 and 5 look the easiest to me to do, and then followed by 2, and then the other ones look like they're going to be more challenging to me. All right, so I'm just going to attack 4 first. And if I were to write that down, I certainly can read what they're asking me, but let me write this down for you. 4 is 2f of x plus f of 1 minus x is equal to x squared. And it says it's true for all x. And its question is, what's f of x? Well, I'm going to say let u equal 1 minus x. And that's the case, I'm going to say x would equal 1 minus u, and x squared would equal 1 minus 2u plus u squared. I'm going to make that substitution now. So you get 2 f of, well, x would be 1 minus u, right? Plus f of u, and x squared would equal 1 minus 2u plus u squared. Now, this might seem strange to you, but I'm going to make another substitution. I'm going to say this might seem strange to you, let u equal x. Well, if it did that, what would you get? You would get 2f of 1 minus x plus f of x equals 1 minus 2x plus x squared. Now, what I'm going to do is I'm going to use this and this to eliminate the the f of 1 minus x. And the reason for that, I don't want that. I want this. So I'm going to take the top equation. I'm going to multiply it by minus 2. You would get minus 4 f of x minus 2 f of 1 minus x equals minus 2x squared. I'm going to take this and I'm going to add it to that. And what do you get? You're going to get, let's see, you would get minus 3 f of x. Let me make sure I get this right. And let me tell you what I'm doing over here. I'm adding them together, so this and this disappears, and this would give you minus 3f of x. All right, let's go to the right side. We're going to add that together too. And what do you get there? You would get, let's see, 1 minus 2x minus x squared. All right? I'm almost there. What I'm going to do is I'm going to divide both sides by minus 3. And what do you get? You get f of x equals 1 minus 2x minus x squared over minus 3. Let me just clean it up a little bit. And what are you going to get? 3 on top. I'm multiplying top by x squared, by minus 1. So it's x squared plus 2x minus 1. So I'm done with that. And you know what? I want to see if I'm right. So I go to number 4. X squared plus 2x minus 1 over 3. Okay. Just give me 1 second. Got a message coming in here. All right, sorry about that. Okay, so I'm done with that one. It wasn't bad. A little substitution error, got brought things together, and that was pretty easy. So I'm going to erase this over here. I'm going to do another one. And I'm always looking for the lowest hanging fruit in the tree before I start to climb the tree and those more difficult problems. I need confidence. I need some nourishment. So 4 turned out to be pretty simple. Let's look at number 5. And number 5 says the polynomial, let's write this down, this polynomial here, x4 minus 27x squared plus 121, it can be factored in a unique way into a product of two quadratic polynomials. Well, I'm going to say those polynomials are going to be x squared plus, let's see, bx plus c. And, whoa, excuse me 1 second. I just almost dropped the computer there. Cancel. Give me 1 second. A little bit. Let's take a look here. So then I put the other one down. It's got to be x squared, right? Because x squared times x squared is x4. And then I'm going to, you know what? I'm going to use different letters. The reason I don't need a leading coefficient of a. So let me just erase this and erase this. And I'm going to do AB now. Because I don't need a leading coefficient of an a, and I realize 1. Let's see. Plus CX plus D. Now I'm going to multiply it together, and you're going to get x4. I got to be real careful here. Plus CX cubed plus DX squared. All right, this one's done. Let's do the next one. What's the next one going to be? It's going to be AX cubed. I'm doing this one now. Plus AC x squared plus ADX. All right, I just finished that. Let's do this now, the B. So what are you going to get? You're going to get plus BX squared plus BCX plus BD. All right, I got some things to write down now, and it looks pretty complicated, actually. But what I do notice is by equating coefficients, I'm going to say there's no cube terms. So that to me means that A plus C must equal 0. All right? And I also notice I have no x term. So these should really add up to 0 as well. So it means they're coefficients. Let's write this down. AD plus BC must equal 0. All right? Now what else do I know for sure? I know that BD has to be 121. The tough one comes here, though. I know that D plus AC, this is the x squared term, D plus AC plus B must equal minus 27. All right, so let's just be really careful now. And I'm going to say that A would have to equal minus C. And then I'm going to say over here that if A is equal minus C, I could write down AD minus AB using the second line. And why is that? C could be minus A, right? And that would equal 0. So that means these have to be equal. All right, so I got some information over here. And what else does that say? It says, well, gee, let me just read that. The polynomial can factor in equating product to two polynomials, linear coefficient of 1. What is the sum? I'll get to the sum. But I'm going to say now that D, unless A is 0, but that's not going to happen. D equals B. D equals B. Wow, look at that. So I got this over here now. And D must equal B. But I got problems here. And I'll tell you what the problems are. What the B times the D is 121. So, if B equals D, it could be 11 times 11. That's 121. And B would equal D, by the way. Or it could be minus 11 times minus 11 equals 121. All right? It's either one or the others. All right? So we're going to keep working around this. And I'm kind of looking at this guy over here. And let me see if I can write that down. And again, D equals B. So D and B are the same. So this would be 2B And let's see, AC, and AC are opposites, right? So that would be minus A squared, right? Equals minus 27. All right, let me write this down now. 2B plus 27 equals A squared. Let's hope I didn't make a mistake here, but I'm going to take a look at it. And I got to take a look now. And it says they're integer coefficients, right? Let me just take a look at that. A polynomial can factor in equating the product of two quadratic polynomials. Oh, integer coefficients. So let's test it out. And I don't know, let's try 11. 2 times 11 would be 22 plus 27 would be equal to A squared. So 22 and 27 would be 49, and that would equal A squared. And so A, well, that'd be 7, right? Plus or minus 7? You know what? I'm going to try minus 11. See what I get over there. So 2 times minus 11, right? I just tried 11, by the way. I might as well try minus 11. That would be minus 22. Again, this is if the D equals the B equals 11. Now I'm saying the D equals the B equals minus 11. And that would be minus 22 plus 27 equals A squared. And this would be 5 equals A squared. Well, that's not integer. So this is out of the question. So I'm going to say B equals D equals 11. We can check this, of course. And then I'm going to say A is plus or minus 7. Well, you know what? I got some nice symmetry here. So let me put this down for you. So x squared, and then I got the B and D both being 11, right? So plus 11. And I got the x squared plus 11. Now, what do I mean by nice symmetry? You notice this A and this C over here. Like if A is 7, this C would be minus 7, and vice versa. So I think I'm pretty comfortable saying this. Minus 7x and plus 7x. All right? And if you want, you can multiply it out. And, you know, you can. If it's a competitive exam, I wouldn't be multiplying anything out right now. I'd be thankful I got to the end of it. But I'm really not at the end of it, right? It says, what's the sum of those? What's the sum of these two polynomials? Well, I got to write that down now. So if I were to add these two polynomials together, and they're talking about these two polynomials here, this one and this one, that would be 2x squared. Well, minus 7x is 0. And then what do you get? 22. That's the sum of those two polynomials. Let's go to the answer key. And this is number 5, right? So let's take a look at it. And number 5. That's a long key, isn't it? Yeah, I'm seeing it right over here. All right, let's go back. Let me erase this. And I'm going to look for another piece of fruit to pick. And let me get my eraser out. I'm done with this. And again, the blue area is typed up for you for a reason. You should think about, at some point in your careers to type things up. And the product that I'm using here is called LaTeX. It's something, if you're going into mathematics, you want to learn that. So, I'm going to say, I think I'm okay with these two. I'm going to look around. And you know what? I think I'm going to try 2. Because the 1 looks tough and 3 looks tough to me. So I want to read 2 to you. There's a lot of reading, though, isn't it? It says in the figure below, this is figure 72 on page 279. Yep, we're on 279. It says the arc SBT, I see that, is 1/4 of a circle with center at the R. I'm looking at that figure, and radius R. And they got it labeled nicely. It says the length plus the width of the rectangle, right, is 8. And the perimeter of the shaded area is 10 plus 3 pi. Well, you know what? I'm going to label these sides here for you. What I mean by that, I'm going to say this is x here, and this is y over here. And what did they say? They said the length plus the width of the rectangle. That means x plus y is equal to 8. Now something else I know about this thing, it's a quarter circle, so I'm going to draw the diagonal in now. And the diagonal looks like this over here. And that's just r. So r is going to be equal to the root of x squared plus y squared. Or you might want to say r squared is equal to x squared plus y squared. You could say that too. All right? Now what I want to do is that they told me the perimeter. All right, so I got to go through this. And I'm going to try to do one thing at a time. And I'm going to talk about these dimensions over here. And that, because the perimeter of the shaded area, right? That's going to be r. By the way, when I put an r down, I realize in the notes you're seeing a lowercase r. I just have a tough time writing that down, so I use the uppercase r. So the radius minus x for that region. And now I'm going to do this little small guy over here. And what would that be? It would be the radius minus y. And the diagonal, right? The diagonal is just r, the radius. That's all that is, right? If you notice this part here, it's the diagonal is just the same as this over here, just the radius, right? So I'm going to write down what I'm seeing now, and I'm just going to go, upon what I'm doing. I'm going to be writing down this, 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 and then the arc, one at a time. So what do I know? The perimeter, let's write this down, is 10 plus 3 pi is equal, I'm going to start here, r minus x plus r plus r minus y plus, I got to do the arc now. All right, he's got 1, 2, 3. I'm going to do the arc now. What's the arc going to be? It's 1/4 the circumference of the circle, which is going to be pi. I'm sorry, I misspoke. 1/4 times 2. I did it again. Times 2 pi r. All right, let's see if I can figure this out. By what square? Oh, find the value of r. I'm almost there. I'm almost there. And let me see if I can do this. So you get 10 plus 3 pi equals, let's do the 1, 2, 3r minus x plus y, and then plus 1/2 pi r. I don't like the fractions. I'm going to multiply both sides by 2. Right, so what do you get? 20 plus 6 pi, 6r, minus 2 times x plus y, plus pi r. All right, let's keep going. 20 plus 6 pi equals 6r minus, well, x plus y is 8, right? So it's going to be minus 16 plus pi r. You're going to get 36. I'm adding 16 to both sides. Plus 6 pi equals, I'm going to factor an r out. This is r. And this is going to be 6 plus pi. Let's hope I didn't make any mistakes. 36, whoops, plus 6 pi divided by 6 plus pi is equal to r. I'm going to do a quick look over it and see how I did. So r minus x, again, I'm using uppercase R for the radius. That looks pretty good. R minus x plus r minus y, and a quarter of a circle would be 1/4 2 pi r. Yeah, I think I did okay. So, let me make sure I've answered the question now. What was the question? The question is, find the value of r. I'm pretty sure I found the value of r, and the value of r, I'm listing down. I'm looking at this thing. It looks like the top and the bottom might, I'm able to simplify it a little bit further, right? So let me factor a 6 out. And what do you get? 6 plus pi over 6 plus pi. And that's what r is. And what do I notice over there? It's just 6. All right, that's my answer. So I would recommend looking at the key. Things worked out pretty nicely there, didn't they? So that's what number is that? That's number 2. So let's go to number 2. Yep, that's 6. All right. I'm going to get the eraser out and start to erase things. And again, if you get, especially on a time competitive exam, be happy you're getting some of the questions correct, by the way. Sometimes people walk from a competitive exam, they get nothing right. I mean, they can't even start the exam. They look at the question, have no idea where to start, all right? Now, I think the reason for that is a lot of people go into competitive exams, they're not ready for them, all right? So what I'm going to do is, I think I have 2 remaining questions. And I just want to emphasize again is, I want to, again, I don't think that was a bad question, number 4. I think it was pretty simple. I think 5 was also relatively simple. And I think 2 really kind of worked out nicely. Now, I want to talk about number 1. And number 1, it's trigonometric. And certainly there's many ways to do it. I'm not saying there's one way to do it. What I want to do is I want to, cut to the chase on this one over here. And I want to walk you through my typed up solution to the problem. All right? Now, granted, someone might say, I got a better way of doing this thing. And we're not denying it. But I want to, point out some of the things I mentioned in this over here. One thing I mentioned is cofunction identities. So what I want to write down is, the cosine of theta is identical to the sine of 90 degrees minus theta. And you could write a whole series of these things down. For example, you could say the sine of theta is equal to the cosine of 90 degrees minus theta, so forth and so on. So, what I do is I look at the problem and I notice that, some of these are cofunctions. For example, 10 and 80, that sums to 90. And 50 and 40 sums to 90. Right? So these are all cofunction identities. So the first thing I did was I wrote down this guy over here as, I'll write this down for you. So the sine of 40 degrees, I wrote it down as the cosine of 90 minus 40, which would be 50 degrees. All right, so that's right over here. And then I wrote down the sine of 80 degrees is the same thing as a cosine of 90 minus 80, which is 10 degrees. So I got this over here. All right, so I'm going to erase my cofunction identity. I kind of understand that. I'm sure you do too, that if you've taken trig, you've had cofunction identities. So I'm at this level here now. All right, so everything is in terms of cosines. So what I start to do is I start to realize that, maybe I could rewrite this a little bit differently, and it might help me out a little bit, because I'm really not seeing much to do with this. So what I wrote down is, I want to put down looking at, I got squares. It's almost like you have an x squared, plus y squared minus some number over here. And I could rearrange that to get this thing to be squaring out. So, certainly, hopefully you know about how to rewrite things to square them, but there's going to be something that happens with that, all right? So let me get my little eraser out, and I'm starting to see something over here. So what I see is, I'm going to write down for you. I'm seeing that I could write this as something being squared. And what am I going to write down? I'm going to say it looks like cosine 10 degrees minus, right, the cosine of 50 degrees. But there's a problem. If I were to square that, I would get cosine squared 10 degrees, and I would get cosine squared 50 degrees, but then I'd get, I'd also get this over here. I'd get minus 2 cosine 10 degrees cosine 50 degrees. But I didn't want 2, I only wanted 1, right? So what does that mean I have to do? That means I got to add something on, right? So if I were to square that, I'd have minus 2, but I don't want minus 2, I only want minus 1. So what do I have to do? I have to add, right? So we're hoping this makes sense to you. And let me write this down over here. So I'd have to add on cosine 50 degrees cosine 10 degrees, all right? So that's this line right over here. Okay, let me get my eraser out. We're just marching through it one line at a time. And yep, I know it's tough. So we're here. So this doesn't help me at all. So what I want to do is I want to talk about, looking for things that you're familiar with. And, some of the things I'm familiar with are what's called product of sum formulas, right? So I'm gonna remind you that, certainly if you do cosine A plus B, you would get, cosine A cosine B minus sine A sine B. And this is how your teachers probably taught you sum to product or product to sum formulas. A minus B, and that would be cosine A cosine B plus sine A sine B. All right? So, what do I'm looking for product. So I would just add those two together. So if you did that, we get cosine A plus B. Let's see what I get there. No, I'm going to subtract it. Let me put that down. Minus cosine A minus B. Maybe I'm going to erase that. I'm going to try a different one. I'm going to do cosine A minus B minus cosine A plus B. There's a point to this, by the way. We're just looking for something that we can use. So I'm going to subtract that. I would get 2 sine A sine B. All right, let's take a look at it. And so what are you doing over here? I'm trying to figure something out over here. And I do see I'm going to say A minus B is the 10 degrees, and the A plus B is the 50 degrees. Well, if I add that together, what would you get? You would get 2A equals 60 degrees. So the A would be 30 degrees. All right? What would the B be, though? The B would be, well, if the A is 30, the B would have to be 20 degrees. All right? So I'm going to say the cosine of A minus B, which is 10 degrees, minus the cosine of A plus B, which would be 50 degrees, would be the same as 2, well, sine of A would be 30 degrees, right? And then sine of B would be 20 degrees. Sorry about jamming this stuff in here. You know what? I got to erase it because it just jammed in too much. I apologize for that. So let me write that down for you. The cosine of A minus B is 10 degrees minus the cosine of A plus B, which is 50 degrees, would be 2 times the sine of A, the sine of 30 degrees, right? and then you're going to get the sine of b, which is sine of 20 degrees. All right? So, what do I get? Cosine of 10 degrees minus the cosine of 50 degrees. Let's be very careful. And a 30-degree triangle looks like this over here, 1, 2, root 3. And the sine of 30 degrees is what? It's just 1/2. So this would be the same thing as sine of 20 degrees. All right? So I have this now. And what is this over here? It's right over here. Now, sine squared at 20 degrees. All right, I have that. And so let me, maybe I should write that down for you. So it's going to be sine squared 20 degrees plus cosine 50 degrees cosine 10 degrees. All right? And I want to concentrate on what I need to concentrate on. So I'm kind of done. Get my eraser out. I'm done with this. I'm done with this. And I want to move on. Right, so I'm looking at this, and things are getting, you might say they're getting worse. I don't know. But I'm kind of looking at that. And let's see, cosine. You know what? I'm going to take this up, the identity we just did up here. I'm going to get rid of all this stuff over here. And I'm starting to see another, like, sum product relationship. Right? Let me just get rid of this over here, too. Kind of done with that. And I'm seeing, the cosine. So what I'm going to do is add these two together now. So cosine A plus B plus cosine A minus B. And if I add those two together, what do you get? I would get 2 cosine A cosine B. All right. Let's see what I can do there. I'm going to say A is 50 degrees. And I'm going to say B is 10 degrees. Let's see if that works out. And what are you going to get? Cosine A plus B would be 60 degrees plus, well, you're going to get 50 minus 10, so cosine 40 degrees. Yeah, it's tough, right? Is the same thing as 2 cosine 50 degrees cosine 10 degrees. All right, let's take a look. What's a cosine of 60 degrees? It's a half. Plus cosine 40 degrees equals 2 cosine 50 degrees cosine 10 degrees. All right? I'm going to divide both sides by 2, and you're going to get 1/4 plus 1/2 cosine 40 degrees is equal cosine 50 degrees cosine 10 degrees. Let's write that down. Sine squared 20 degrees plus 1/4, right, I'm doing this over here now, plus 1/2 cosine 40 degrees. All right? Again, you might think things are getting worse. Maybe they are. But I'm noticing 40 and 20 have a relationship. They're doubles, right? So what I want to write down is a double angle formula. And so I'm going to write down, let's put this down now. The cosine of 2 theta is equal to 2 cosine squared theta minus 1. So the cosine of 40 degrees would be the same thing as 2 cosine squared 20 degrees minus 1. It's a lot of work, isn't it? Let's write this down now. So I'm going to take this and rewrite it as sine squared 20 degrees plus 1/4 plus 1/2. And the cosine of 40 degrees is this thing over here, which is 2 cosine squared 20 degrees minus 1. I've got some work to do, don't I? Let's write this down. Sine squared 20 degrees plus cosine squared 20 degrees. And let me just make sure I'm accounting for what I said I was going to account for. So I just did this, and I just did this part over here, because a half times 2 is 1. And then you get some numbers left over, right? And what numbers you get left over? Plus 1/4. And then you're going to get minus 1/2, right? Ooh, that's going to be a tough one. Not really. Look at this. This Pythagorean identity. It's the number 1 plus 1/4 minus 1/2. And let's see what you get over here. You would get 1 minus 1/4, which is 3/4. All right? Not bad. All right, now I know this has taken a long time. It's longer than usual, right? So that was number 1. I just want to cut to the chase over here. I know it's difficult, by the way, but let me go to the other question I didn't answer. And one I didn't answer is one I was really saving for last. And yeah, for a lot of students, it is nightmarish. And let me go to number 3, and I'll talk through it, all right? But again, if you're in a competitive exam, you got 3 of those questions right, you consider yourself pretty good. In a timed environment, by the way. If you had all day long, you should get them all right, especially with the internet nowadays. You can look these things up. These questions are they're all over the place. So it says let them be the distinct real solutions of this equation over here, with the understanding that this is the floor function. And we've discussed this in other parts of this document. And this is also called the greatest integer function, but it's a floor function now. So it says compute. Oh boy, I got to find a solution, then cube them. All right. So what I got to determine is what these things look like, and this is where a lot of work goes into it. Right. So they're really in pieces, and I want to tell you why the floor function. When I look at the floor function, let me put this over here, an axis. The floor function looks like this. And then it jumps at the integers. It's also called a step function. It just keeps jumping, all right? So you have to really determine what interval you're on. So for example, if you're on the interval from 0 to 1, the floor would be 0, right? And that's why I wrote this down over here. So if you're between 0 and 1, right, including 0, but not 1, the floor function would look like this over here. All right, now if you want the interval where you started at 1 and went up to 2 but didn't touch it, let me just make sure I'm saying this right. It's 3 times the number 1. Then the next one's going to be 3 times the number 2. Then the next number is going to be, let's see, did I say that? 3 times 3. And then it's going to be 3 times 4. I think you see what I'm doing over here. By the way, if you don't see what I'm doing, I'm talking about the numbers here. 3 times 0, 3 times 1, 3 times 2, 3 times 3, 3 times 4, so forth and so on. And again, we're talking about being on these intervals. Now, by the way, I always have an easy time going forward. It's going backwards sometimes I have a tough time with it. But going backwards, I want to point out, if you looked at the floor function going backwards, it looks like this over here. So then between, -1 and 0, it would be minus 1, and minus 3 times minus 1 is plus 3. All right, and then plus 6, so forth and so on. So I'm hoping it's sort of obvious why I'm writing these things down over here. All right? And I'm not saying it's easy to do that. I'm just saying that you start to see a general pattern to it. And the general pattern to it is basically these things over here on the intervals. And then what you got to do is you got to solve for x for each of those intervals. And that's tedious, I'll be honest with you. But this one doesn't seem to be too tedious. So if you were to write it down, I mean, this equation over here would just be x cubed equals minus 2. If you wrote this equation over here, it would be x cubed equals 1. If you wrote this equation over here, x cubed would be equal to 4. If you wrote this equation down, x cubed would equal 7. If you write this equation down, and this goes on forever, by the way, x cubed would equal 10. And there's a pattern to this as well, by the way. X cubed would equal 13. X cubed is going to equal 16. I just want to look at the pattern, and I hope you realize the pattern. It's kind of jumping up by 3 each time. All right. Now, again, what I'm talking about over here, just looking at it, right? 1 to 4 is up by 3, up by 3, up by 3, up by 3, up by 3. And it goes down by 3, too, if you want to look at it that way. So you could write this all day long. I wouldn't suggest it. That would be minus 5, so forth and so on. Really what I'm concerned about is a solution to those problems on the interval it's supposed to be on. Because if the x is not there, it couldn't be a solution to the problem. So that means you got to solve these things separately. And what are you going to get over here? Well, you would get x equals the cube root of minus 2. And that's certainly on the interval. And now if you did this one over here, you would get x equals 1. That's not an interval. So this is no good. All right? What do you get over here? You would get x equals the cube root of 4. The cube root of 4 is 1 point something though, right? That's not there. So forth and so on. So you're kind of looking around for solutions that are in the interval. And you start to realize there's really not many. I mean, you got this guy. That's one of them. You got this guy. That's one of them. You get the idea what I'm doing? You get this guy. That's one of them. And I'm going to say that's it. All right? That's it. They're the solutions to the problem. Right? Now, I'm going to say also, possibly graphing these things out may indicate that to you. All right? And this is a graph. Right? And again, I'm going to, kind of highlight things for you. This might help. May not help, though. All right, may not help. But I'm only going to get 3 solutions to it. So someone says you got 3 solutions to it. What was their question? Their question was, compute the sum of their cubes. I think I can do that. Right? So what are you going to get? Well, the cube of the cube root of minus 2 would be minus 2. That's that guy right there. The next one's going to be the cube root of 7 is 7. And the next one's going to be the cube root of the cube root of 10, which is 10. And that's going to give you 15. Well, let's see if we got the answer. Yeah, 15. All right, 15. All right, my rough graph. Let me see if I say anything else about it. Yeah, 15. All right. So very little. That to me is the toughest problem, no doubt about it. It requires some thinking, computation, understanding where cubes were and cube roots, yada, yada, yada. So here's the deal. My email address, B as in boy, ANNON.US. Again, I don't think I'm going to be too busy with people emailing me, but you never know. However, if you have a question or concern, please feel free to reach out to me. If I'm not overwhelmed, I'll get back to you. All right? So I just want to go back and review a little bit of the questions. And in hindsight, I'm going to tell you what I felt to be the easy questions. And again, we may disagree. But I thought 4, I thought 5, and I thought 2 were easy ones. The ones that I found to be difficult and tedious to do was 1 and 3. All right, I found them to be tedious and difficult to do. They took time. The other ones are kind of straightforward though. So again, a strategy in general, look for things that you like doing. All right, do those things first, then do the other ones last. This one over here is a little bit brutal, but again, someone might say, well, I see something better to do. Please share it. All right, please share it. You may see something better to do in this one over here. Again, please share it. And again, how do you share it? You write me. You write that email address. And again, if I'm not overwhelmed, I'll get back to you. All right, I'll get back to you. Thank you for paying attention. I really appreciate you paying attention. Thank you.